Okay, so we are live, and oh, would you look at that? Today I am playing this playlist by I don't know, just you can see the title, right? Work, study, lo-fi jazz. Okay, I thought it'd be nice to show what I'm listening to, because since I'm not paying for it already. If I yeah, I don't know. I hope I don't get copyright struck. Okay, anyway, today the goal is to try to code a solver for the game Wordle. And Wordle, I don't know if you guys know this game. It's been super popular in the past, I guess, week. Oh shoot, did I just close my music? I'm stupid. Sorry. Okay. Yes, now we're back into the relaxing mood. Yeah, so basically the game works like this. There's two modes, easy and hard. I'll just explain the easy one first. So you guess a word. There's a 5-letter word that you have to guess, and you make a guess, and you will be told if the letter is in the correct place, if it's in the wrong place, which is denoted by yellow, or it does not exist in the word, in which case it is kind of grayed out. And then you use that information. You carry on making guesses. You could, so in principle, you could guess anything you want. You could even guess the letters that are wrong, I guess, even though it's debatable if that's completely useful or useless. And yeah, that's about it. That's the main idea. It's like a combination between Mastermind and Hangman, if you will. And the hard mode is when you have to use the letters which are either correct position or wrong position, but it exists in the word. Basically, you are not allowed to guess completely new set of letters once you sorry once you have some sense of what's right and what's wrong. That's the hard mode. Okay, so so my buddy and I and Diru, shout out to Diru if you're watching, or whoever knows him by any chance. So we've been talking about it, and yeah, he has a solver that he wrote, and I figured it would be good if I can do something like that as well, just to figure it out, just for fun, really. I mean, nobody cares. Well, and the more I thought about this problem, the more I guess surprisingly complicated it gets, because so naturally the few approach, I mean, okay, by the way, I have not thought through any of this, so this is going to be a very messy and a rambly video, but the goal is for me to I guess quickly get to the end point by running into things. So the idea is that, so if we take this word for example, so the first word I guess is moire, which is I guess a French word or something. Oh, moire, yeah, I know there's like a math thing, moire patterns. Anyway, so I guess this because I like the fact that it has 3 vowels, and then it also has the letter R, which is quite common, and letter M, which I guess is it appears sometime. So the question that I have in mind is, so if I have O and R, in this case, if I know O, do I therefore try to eliminate every single word that does not have the second letter at O, and then play on from there? Or I could do something completely different and hopefully end up with a solution. So it's not so straightforward. So basically the challenge is the trade-off between explore and exploit, which is a very common thing in any type of I guess limited resource optimization problem, in some sense. So I have a few approaches to go about this, but okay, let me just start right away. So I've opened up my lab already, Jupyter Lab, and I've downloaded the word bank. Here it's on the words dot dat. So let's see if I can open it. Do I use open? I don't even know the word. Open. Something like read. I don't remember. Words is not defined. Whoops. Because I'm yeah. Something like that. And what would A be? And you read it, and then you get this, right? Say read method from the street. What does W look like? It looks like blank. Very good. So first thing I need to figure out is how to open a goddamn file. I've tried looking this up, but CSV delimiter. Wait, you can use CSV? I guess pictures does not contain the file. Check both CSV. Pandas read CSV. Delimiter text.read. Pass text as first argument to read CSV. It's clearly clean up before I process it. The following code converts into a CSV file. Read lines. Read lines. See if that works. I'm just trying to. I'm so annoyed. Why is it so hard to open a file, huh? Wait, what did I do just now? Eh? Wait, what did I do? Yeah, a.read, right? Hold up. Oh, then it's gone. I see. Then if I do it again, then it's nothing. Fantastic. Okay, so I should have everything. Oh, what the? Can I check the delimiter? Can I? Is there like a delimiter? Oh man, this is so messy. Okay, fine. Whatever, right? So each one of them, I just take the last two. So, it's a cheat. Oh shoot! No, up to the last two. My bad. Very dirty and cheap method. But it. Oh, up to the last. Wait, what? Why? Oh. Okay, there we go. It works. I mean, it's cheap, but it works. So now I can. Sick. Okay. Yes. So now we're ready to start. So this W just tells me all the words there are in the English language according to some banks. So it may not be complete or perfect. Or even correct. I don't know. There's probably some errors. It's bound to happen, I guess. Then there's all the 5-letter words, right? So from A all the way to yeah, and a bunch. Cool. So so naturally the most easiest thing to do is okay, let's just think about the most easiest way to fix. Let me just go to Wordle to go for to try to solve the game. So the most obvious strategy that I have, I mean the most basic thing, is just to guess, and then you narrow down whatever it's possible. So how do I want to do it? So naturally I want to do a filter, right? So that's the main challenge, right? Well, not really, but okay, doesn't matter. Let's see, how do I want to go about doing this? Okay, let's just write a version of the solver that works, or rather just a basic brute force narrowing things down solver, right? So I guess a word, and then you go down, and then you narrow down. Okay, so you pass in the dictionary. If the dictionary tells you the solution, tells you the space, then you check if it is. So respond. So I have a dictionary. And then I have the target word, of course, the solution, and then the dictionary. Oh no, I just want to filter by hint. Well, no, I can do two things, right? So it must be okay. Filter by correct. Okay. Okay, so what I have in mind is that so it'll be a dictionary. So for DD and D, so for I guess letter position. So for each letter and each position, maybe I should make my editor larger here. Okay, is that easier for? It's a bit too large and looks a bit wacky. Yeah, so for each letter, so let's just say that filtered list is empty. So this is by the correct position. Filter by correct position. So that means, let's say I give the word hey, hold on. Oh, okay, already I'm starting to be a bit okay, there's a couple of ways to do this. So I want to check if if all of them are true. So I should check for each word instead. So for W, W, and W, and then correct. Oh wait, let's say valid. So each word I want to check the validity. Validity meaning to say that everything must be fulfilled. So so that means to say at some point I have to have my letter, the word has to be equals to letter. Yes. So that means to say, okay, let me write this down. I know it's a bit. Let me write things down. Okay, so if I say something like I want my word to, well, let's see, I know for a fact that this is gonna be an A and then there's gonna be an R, say, then what that means is that my second position must be A and then it must be R, and I have to check all of these things, and they all have to be true. They all have to be true. Yeah, so letter position in d.items, something like this. So this is I go bool and then if boolean.sum equals length dot boolean. Okay, so then now filter by exist. So hey, how's it going? It's going, I mean, it's just started. So I'm writing this function. This function's filters words with correct position. Actually, you have to take in you know, let's call it L. My conventions are very, very bad. So, oh, by the way, I set the text to disappear after a minute. So, actually, I'm not sure if that's the best idea, because if I don't see it for a minute, it's gone. Now, so be it. With letters at correct position, so you get a word list. So word list, and then you get a word list as well. So it's actually kind of similar. With letters that exist. Okay, so it will be every word in the word list, and so if letter in word, yeah, so letter in the word for, then it'll be the sum. It'll have to have all these true. Okay, this looks all right. So let me just test it out. Okay, test it out. So I want to, my test dictionary is that also I don't know how I want to write this. Okay, it doesn't matter. It doesn't. Let's just test our logic first. So D, I'm gonna say that my first letter is gonna be an A, and my last letter is gonna be a T. It's gonna be a T, so 0 to 4. So this should tell me all the, oops, list is no attribute sum. Really? Ah, it's sum. Whoops. So these should be all the words that start with A and end with T. Cool, it works. Beautiful. I mean, okay, if you're a computer guy, don't hate on me, because I know my implementation is probably very redundant and inefficient, but it works. And I mean, given a list of 5,000, who cares? It takes maybe another extra second. Okay, so this works. Very nice. And filter by, so filter by hint. So now we have the existence, and then correct B. So now I will take word list filter by correct by W, and then correct B, and word list equals filter by existence, word list by exist E, and then return word list. So now I'm gonna try again. So now I'm gonna say that my word has to have has to have A, well, let's call maybe E in the second letter, and then A. Oh well, doesn't matter. Let's just say it has E as second letter, and then oh, sorry. So this would be E in the second letter. And then wait. Yeah, okay, I can deal with that later, but let's just say that it is correct. Okay, okay, I think I should do by letter. Okay, let me just change this, because I think this is not very efficient. Position and letter, right? Wait, so for every word in the word list, you just append it. If your word position is equals to the letter, and then this would just be the dictionary. Dot items. So if position is more than 4, 1, 2, 3, 4, 5, more than 4, so I start with W and then filter by existence. Oops. So this will be word list, and then it will be the letter. Else word list equals filter by correct position, and then this would be my word list, and then the correct, it have to have the position and the letter. So it'd be letter and position. Let's call letter and position instead, just for neatness. Okay. So the word list. Okay. So now let me just change things. So I want to say that my hint I guess hints. Hints, okay, so if the hints would be that my first letter, my E has to be a second letter, and then it has an S inside. And then it has also a T. Okay, a T inside. So let's see if that makes any sense. So these are the words with B, with second letter E, and then with S and T inside. Very nice. So it works. I mean, the filtering works. Let's just say that I want my T to be the first letter. Now it's much less Very nice. Okay, cool. So we know this works. Filter. Okay, let me visit the washroom real quick. Hello? Yeah. Okay. I think I went to pee and I had a thought. So clearly, so let's take an example where you see, you have all these words, and actually the next one you have to think is, how do I pick them, right? That's the main core of the game, right? Like, how do you go about picking them at all? So which means there must be some way that we want to rank these choices, and then we pick the top one, right? So so intuitively, there are, I guess, two main ways to think about it, and maybe the best way is somewhere in the middle, which is what I'm proposing. So first, the way to think about it is that I want to pick the word that has the most common letters. Okay, so I want to pick the word with most common letters. So for example, in this case, words like, I guess, like Texas, or like text. Well, maybe not this. Let's pick a good word. Let's just say Texas. Texas may not be the best word because there's an X in it, and it's very few words that's an X, right? So that's in some sense that's not the best. In I hope you can get what I mean. Maybe you want to pick something like teals, right? Where T-E-A-L-S all are very common letters, which means to say even if you get it wrong, there's a good chance that the L, maybe the A or T, whatever, might show up somewhere else. Yeah. So you get somewhere. So that's how you progress. Another way to think about it is that if you pick something like Texas, there's a low chance that the X will help you, right? There's a very low chance. But if it ever does, then you are gonna win really quickly. So for examples, if let's say I do this and then it turns out that there's an A in the word. that the A is in the word, and then you are, maybe you're left with this, Tesla, Texas, you have like 7-8 choices. But if you pick something like Texas, what if X is in the word, but it's not Texas? Let's say you get it wrong, but X is in the word. Then suddenly you have only one choice, text. So the trade-off is between picking a common letter so that you get you are likely to get some information, but the information might not be useful or very, very informative, versus having a low chance of getting a piece of information, but information is going to be super rich, right? It can tell you a lot, and that's the trouble here. So I don't really have a clear idea. I know that the idea is probably entropy. Maybe I want to tap on that a little bit. But either way, now we want to go ahead and formulate ways to rank the words. So for one, let us first compute the distribution of letters, right? Just all the words. How often do the letters appear? So I think that's an interesting thing that I don't know about. So let's figure that out. So how does that work? So that means to say, so let's just call the alphabet A, B, C, D, E. I don't have to. Okay, let's just do it according to order. I could do it in any order I want, of course. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Right, so just to check, I can of course check that my length is 26. And then now I want to create the dictionary. So letter 0, 4 letter in alphabet. Let's just call this string. Like this. Oops. Little syntactical error. Okay, so now my alphabet is just a bunch of a dictionary full of all these things. And now I want to go, so let's call it frequency by letter. So okay, let's just let's just do it slowly. Okay, I know I can do it in one line if I really wanted to using comprehension, but let's not bother. So for every word in your word list, and so for every word in your word list, so each word has 5 characters. So letter in word, alphabet, no, frequency by letter. I don't even need the alphabet really, do I? I'm so stupid. So now I just add the letter. Oh no, I do need yeah, because it's, well, I mean, so just if letter is in your freq by letter, then frequency by letter, letter plus 1, else frequency by letter, letter equals 1. That's it, right? I don't need anything else. I'm pretty silly of me to have to invoke that. Completely unnecessary. And then the for every letter. Okay, right. So this should contain all the thingies, and I guess we can plot this. Can we try to plot this? Okay. So free by letter keys. I don't know if this works, but items, key values. Probably doesn't work. Oh, what's wrong? Oh, it does. Okay, cool. But I don't need this to be. Oh, can I do like a histogram thingy? Okay, so we can see that, I mean, that's just what it is. So the most common letter, R, S, and E. Ooh, okay. Followed by A, and then R, and O, and the least frequent is Q. Oh, it's not even Z or X. It's freaking Q. Interesting. Surprising to me. Okay. So if you want to go by picking, if you want to go by picking, also, yeah, so if you want to go by picking, if you want to rank the word, first of all, that I think there's, you know, there's different ways you can go about this, but one idea is that you just take the word as a whole, meaning to say, the word steam is gonna rank the same as the word meat. You know, in this measurement, meaning you're doing some type of sum, right? But that may not necessarily be the correct way, because you might want to consider that the letters in their respective positions, right? So this is okay. This is getting complicated already. My point being that if I treat everything as a whole, then I just pick the word with the highest score, then that's whatever. But I also can do it by position, right? By position, meaning to say the most frequent first letter, the most frequent second letter, and go about it that way, and to think about the words that maximize that score. I'm not sure if I'm making any sense at this point, but I'm hoping that I can go somewhere. So okay, so these are the frequencies, and of course I can divide it by. Oh well, do I need to divide it by anything? No, I don't. I mean, I don't have to. Should I? Hold on. Let me write down a piece of math. GB 10 plus 10p. Ln 10p and ln 10 and ln p. So it will be a constant plus. It'll be a constant factor. Okay, not exactly a constant factor, but okay, let's just rank by. So score by overall. I don't know what's the correct word to call this, but frequency. Okay. Is there a faster way to do this? Convert. Convert. No, I don't bother about quickness. Word not in score. Then score word equals 0. Plus equals to the word, the letter. Oh well, no, I mean frequency by letter. Okay. So this means every word now has a score. Can you see this? Every word now has a score. Every word has a score. Okay. Very nice. Okay, so associate to every word as a score. So this is like Astro. So what is the max? Of course, you wanna Okay, I don't really know where I'm going with this exactly, but I think I'm getting somewhere. I think I'm just collecting enough information to do something. So I want to find the maximum score, right? Now I can say, well, okay, so now I know this. Maximum score. Can I do it easily? How to search for maximum in dictionary. The max all values. Key of max value. Python. I don't know. I mean, is there a simple way that is 01? I don't think there is, but... Ooh, what's this? Stats. Stats.get. What is stats? Key. Stats.get. Does this work? That's so sick. What is the... Okay, let me check. Default op key without a single... The default keyword instead of return if it's... Okay, so let's say score get. What do you get out of this? I'm not sure if this is necessarily true. Oh shoot. Yes, there we go. Yes, cool. So that means I can go... Whoops, of course I can just be a bit pedantic and then go max score equals 0, max word equals word 1 for word in score variable frequency if score if score greater than max word equals to word, and then you can go max word follow is Zoe. The freak. And then I need to replace my max score equals to score, so it's S's. So that's the highest scoring word is S's, but clearly it's a bad word to choose because because there's only 2 letters, so you're not... So, that this is interesting. So I don't want to score by just by frequency. I want to score by variety as well. So how about let's just call it such that if they repeat, you don't add the score. Okay, so if it's not in score, wait, if the letter, wait, for every letter, okay, so for the letter, ooh, this is interesting. So the score should only reflect the uniqueness, the unique letters. If you repeat letters, you don't get extra score. Does that make any sense? I think it does. So ES should just be voted as E and S. Huh. Because they don't give you more information. Okay. So let's have another one. Let's just say that... Oops. Let's just say that I am doing like a find max score. Well, define find max score given dictionary of scores. max word. That means now I want to create by. So let's just say total. Okay, let's keep it simple. Score by unique frequency. So score by total frequency and score by unique frequency. So unique frequency is that means to say in a list, get unique values in a list. Is there like a dot unique? I'm pretty sure it's something like that. Set. That is crafty. Does it work? Oh my god. Find max score. Score by unique frequency. Max. What? Max R is an empty sequence? What do you mean empty sequence? Shit. Yes. For letter. Yes. Unique. Shoot. A rose. There we go. So it turns out a rose could be the best word. So the cool thing is now that we've discovered this scoring rule, we can already do better, right? So can I sort? Let me think. Sort. Sort. So a rose is already the better word, because you have 5 different letter words. And then just to check the score by unique frequency, if I check the word S's, it's only 6,000. What a tragedy. And a rose is freaking 12,000. So suck on that, S's. So already we can do this. So let's just, now we have to write the game, right? So I just take, so every time, so when we have a narrowed down list, do we re-rank the words? We don't, I think. Okay, we don't. Let's not do that first. So play game with target word. And then we have the score, the word, the play game. Okay, so oh, okay, wait. So when I find max, Okay, my find max has to be maybe a little bit. So my dictionary, there have to be keys. Words. So that means I have this scoring, but then I need to use the keys of the previous words. Score, and then we have word. Scores and words. Okay, so I'll just go so that this will actually, that means max score equals to 0, max word equals to words 0. So for word in words, if score if scores word, oh my god, WW is greater than max score, then your max word is your word, and then your max score equals to score, and then you return your max word and max score, I guess. You can just return your max word. So find max. Well, words. Oh, okay. So words. If I go by W. Wait, zooms. Zones. What? What? Oh, okay, that means I must have redefined W in some shoot. That's bad. Frequency per letter. Wait, why? Oh, that means, okay, hold on. If the score of this word is better than the maximum score, then the maximum word is now the word and the maximum score is now the score. Return maximum word. Maximum score is 0. Wait, why does that make any sense? Doesn't make any sense. Yeah, it's not. Oh, hold up. Something's wrong. Why would it say zones? Find max score. Oh, find max word. Damn it. Okay, wait, let me just restart everything. Feel like. Okay. Score is not defined. Right? Of course. What am I doing? Okay, so the target word play one round. So you get a target word. You get the score. And then, so one round you just want to respond, right? So it's actually just filtered by hints, right? So the number of rounds goes to 6. 4 in range and rounds. So play one, no, play game with word. So the scoring method and oh wait, so hold up, there's a hint and then there's a filter, right? So I need to generate hint. So which means I need to take the target word and the guess word, right? Okay, so it's either, if it exists, then it could be correct or wrong, right? So for letter in guess word, I guess we want to enumerate it. And then this is position. So wait, did I screw something up from before? So I want to generate a hints dictionary. Generate hints. And so if the letter is in the target word, then if the letter is equals to target word position, then the hints should have that letter in that position. Else, hints the letter equals 9. There we go. So this means to say, if I try to generate some hints, okay, and my target word is, let's say, a rose, and then I guess S's. Oh, shoot. So that means E is in the wrong position. So let's okay, so here we are assuming the word is correct. Right, so if, well, maybe we don't have to say that, right? So if guess word not in W, print invalid, just assert guess word in W, invalid word. Is that how you do it? Okay, so what if I do something like this? Invalid word. Okay, so it throws an error. Oh, what's the input again? Wait. Assert. It's an we assert, then how do I Can I? Well, let's just be super lame about this, huh? Message. But then does it have to be an error? Can I make the assertion, then return none? Assert Python without error. Okay, maybe assertion is not the right way I want to go about it for this one, because I do want to continue on with the game. So let's say if not in, then return none. You gotta print say invalid word. Print invalid word. Then return none. Hints is not defined very well. Hints. Okay, very well. What about I do something like meant? What about arise? Oh, right, but yeah, okay. I forgot about filter. If it's, hold on, generate hints. Filter by distance. Oh, what? Hold on. Filter. Ah, yes. Okay. Find max word. The score given word list. Print. Oh. Print guess word. Generate hints. Play game with the guessword. Let's say meant score by unique. Let's see. Return. Cool. Yes, so 5. Okay. So you guess in 5 rounds. Now we... Five, right? Okay, so let's say oh, did I mess up? Oh, this is taking a while to play the game. Wait, am I tripping? Ah, okay. Adobe would take 99 tries. What? Why? Wait, why? Holy. Yo. Wait. Amoeba. Wait, why? 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 Wait, what? Why wouldn't it at most takes? Whoa, what the heck? Anole. Oh, what the? Huh. Oh, cause it gets stuck. I see. Okay, so I guess the word alone, and then the word alone is already the highest scoring word. So it needs to, so if it's not the right word, so if it's the wrong word, it needs to generate the hint, and then the hint must okay, so it must be del word list guess word. Oh. The least not hold on. It's not defined. Word list is not defined. Ah, yeah, okay. So the word list length filter by hints. So if it's hold on, filter. Remove element from list. Pop. Yeah, so del. I think you can use del. Or what? Del. One. Okay, let's think about this. So the point is I don't want to have wait, but I see. So wait. So when you guess a word, then you just wait. What I can do is you guess. Oh wait, yeah, sorry. Oh my god, it's the same problem. She was very slow though. So how do I, okay, wait, I'm facing such a stupid question. How do I not edit self, right? So if it's filter by hint, and the hints is generated by the word, hints, and then you have the word list. So to find a max, what? Oh, this is so lame. Word list, and then for word list dot append. This is very stupid, but it works. Oh, I don't want to print so many things. It's gonna destroy. It's gonna make it too slow. Huh. There's still some that's 10, huh? Okay. That's surprising for a number of reasons. Okay. So now we have all these words on average. Let's think about the average maybe. So on average you get 4. Okay. On average you need to guess 4. And of course we can check the max and the min. The min should be only 0. Ah wait, so 0, 1, 2, 3. 0, 1, 2, 3, 4. Ooh. Maximum 16. Holy shoot. What? Bears. What? Whoa. Why? Oh, what the heck? Why would it be? So if I place the word bears? Oh my god. Okay, let me check one more thing. So find max word. Print. I guess. With score. With score plus string. Score. Guess word. Possible with 6. Interesting. Wow. Let me check with my friend to see. Whoa, bears. Oh, to string. Oh. Oh no, because I am not I need to concatenate them. I'm stupid. Ah, the hints should be concatenated. Oh my god, I'm so stupid. The hints should be concatenated. Hints. Oh, still pretty bad, huh? Oh no, it doesn't matter. What? Oh my god. So that means if I go filter words by hints. Ah. What about duplicate letters? Wait, what about duplicate letters? Oh. Wait, this is so this in 11. And if I don't do that? What? It'd be... What the... Oh no, actually I don't need this to be... Okay, this is interesting. So the first word is arose and earls. Wait. Wait, hold on. If A... What? The first word is arose, and then my hints were there's no A. Oh wait, there's no I. And A is in the wrong spot. There's no I and no O. And then I get something like this. And then I get something like this. I see. Huh. So finally you guess bears. And then you win because the word is bears after 10 times. Okay, I don't think this is... Okay, I don't think this is necessary. Wait, why is it 11 and 10? Hold up. Here's bears. Wait, what? Why did I... What? Arose, arise. Wait, what? Hold up. Hold up. Generate hints, word list. How can I guess arise? Because this is in the wrong. So my hints are all messed up, huh? Generate hints. Okay. Hints, letter, position. Hints. Oh. Okay, wait, I think about that later. Wait, how can it be a rise? Because I just said that there's no O and A is in the wrong direction. So A, that means my hints. Ah, that means I didn't narrow down. Oh yo. That means if it's wrong, shoot. Shoot. filter. If it's 9, exist by absence. Filter by existence. So filtered word, if letter in end okay. Shoot. String index out of range. Word position. Okay, so yeah, oh my god, I'm so silly. So filter by existence. Filter by hint. That means if the position is 9, the hint items if it's 9. So I need to so it will be negative. Okay, it will be negative 0. Should be 0, and then if it doesn't exist, if it exists, it's 0 to 4. If it doesn't exist, if it's not, then it's negative. Okay, hold up. I have to make this 1 to 5. I have to make this 1 to 5, and then if it's less than 0, and if it goes to 99. Okay, so now I can say that so the position would be if the integer, if it's not this letter, then I filter it. Okay, in the word list position. Okay. So now I need to assign generate hint, I guess. If it's the correct one, so if it's the wrong position, let's say it's 2, let's say it's 1, then that means we're not say it's negative 2. So 1 position, it will be so 1 to 2, negative 2, so it's not at the second position. So in this case it will be not, change to 1, minus 1. Okay, this now looks very messy and probably wrong, but let's see how it works. Okay. Nears, deers, beers, years, here's, bears. Okay, interesting. So let's see if this makes something better. If it's 99, if it's 99, then it means filter by absence, filter by existence. Okay, let's try to see if this works. Okay. Probably it does. I don't know. Yeah, so bears is hard because you get tears and then you're like correct. Okay. Minimum, maximum. So it's more than 5, right? Aging. Wow, asses. What the freak? Okay, asses. Okay, let me. Rows, and then you go NTs. I. Yes, duplicates are gonna have a bit of problem in my solution. I mean, I could just have something like per letter, right? So first letter, I have all these things. It's not this. Filter by the letter. So it is inside. So if I filter by absence, it is the word is and that the give is not in that position. And if it's the correct position, so you can also say it's not in. This is tricky. Let me go to washroom again. Take a little break. Let me turn on the fan. Okay. Alright. I apologize if there's a bit of fan noise. Hopefully not. I think the noise suppression should be working. Okay. So now what I have a problem is that so I need to have a list. Oh, someone sent me a TikTok. Oh, let's not watch it. Let's watch it here. Okay. What? This is like okay, so basically I need to figure out the yeah. Okay, double So if I take a look at all these words that are supposedly the bad. Hey, wait, where's the code? Did I delete it? Okay. Yeah, I can see some of these words have two letters that are repeating oftentimes actually. Butts, cover, dated, dazed, deeds. Yeah, all these two-letter words. So I need a way to figure them out. So if I get them right, I shouldn't override it. I should concatenate it. So I can either do that or conceptually go for something simpler, which is that we have a hint for every letter, which is, I mean, not so bad because you only have 5, but it is a little bit unsavory because you have now checked to 5 things. Can we do it cleaner? Maybe, I don't know. I mean, okay, let's just try. So filter by absence, filter by correct position, filter by existence. So if it's absence is easy. Absence is just that if it's not inside, then it's fine. If it is, then it's not good. And okay, and also the words are sorted actually, so one could use that information to make it more efficient, but at the moment let's not worry about that. So at the correct position, let's just say pause equals position -1, and let's just say pause. Well, no. So it'd be a list. That means my hint must be a list. That means my generate hint. Okay, I got it. I think I got it. Okay, so for every word, and for every pause in position, pause equals pause minus 1. If how do I check if it's fulfilled for every one of them? Hold up. So because letter. So let's say if my A has 3 and 5, that means if my letter is in the 3rd and 5th, Boolean. Right, so wait. Oh, I deleted it? Okay, sum of Boolean equals to length of Boolean. I don't know if that's it. Oh shoot. It's not iterable. It's not iterable. What does that mean? Sum the Boolean equals. Oh no, because I haven't. Okay, wait. So, yes, so it's integer. Okay, so that means we expect a list. Wait, so the hints. Oh. Okay, so the position, it is one letter, and then that means we will check for every letter. So it is the generation of hints that requires special care. So it's a generating hints, right? So the generating hints. So if it's not in wait, so guess what is invalid? The hints. If the letter enumerate. Okay. So if it does not exist, then it's 99. And if the letter is inside the word, if the letter is inside the target word, and if it's the correct position, wait, let's just stop first. Let's play a word maybe. Hmm. Hmm. uh oh. Oh. So it's not. So it's not here. So no, no, then change position. So it's, so there's a, so D is not first or second. E is not fourth. Wait, not fourth. And it's not, wait, E is the fourth. Oh, wait. Okay, sorry. Then A, it's not the first, it's not the third. There's no R, there's no S, there's no U, there's no I. D, E I know is here. A. Hmm. 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 So it feels like what is the score? Wait, A is wrong position. I'm checking with the friend now. D is does not exist. I does not exist. E is wrong position. And then U is does not exist. So he has an algorithm to solve it as well. And I just want to check if it's so hard to solve this word. The word is here, Sears. It took mine 13 tries, which is horrible. "13 tries, jeez." Mm. Oten. I can't tell what is it. Oten. This is tough. So that means ranking the words by Well, no A, no R, no O. It's not worth this. So let's say no A, no R, no O. So let's say um uh so it's no A, no R, no T. So E is the fourth letter and oh. So 4 and 5. So something 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 AS. And it's not AR. Maybe it's no R. No A. No M, no I. Oh, okay, so it is something like IES. Gears. Ba, ba, ba. Interesting. Okay, so let me just give a quick recap of what I have so far. Is that I have built a solver based on maximizing the score of a word this as determined by its the unique character's total frequency. So words with A and E and R and S and T, common letters will score very high. That's the idea. But that's just one way to do things. Really, there's no reason to believe that you have to do things that way. Total frequency. Total frequency is kind of stupid at this point. I don't really care about that. Okay. Let's see here. Now maybe let's try to push a little bit more and then we can call it a night. Let's create a different type of score where we need to take into account of the innovation. So maximizing unused letters. Wow. So how do we take that into account? So if we maximize unused letters, if we maximize exploration, meaning to say we want completely unused letters, which makes sense. Then if it's used before, if it's unused, so if the letter is unused, so let's say you have a shorter list now, and I want to use that, means I only filter by absence. I don't know. So my hints. Okay, so far what I have is that I. So what if I maximize, I guess, innovation or exploration, whatever you call it. Maximize entropy. How do you count entropy? Probability. Oh, but what about the frequency of the word? So what about if you generate a score by so that means this has some frequency. Oh, okay, let's do that. This is quite easy to do. Let's try that out. Why not? So instead of unique frequency, we go score by letter frequency. I don't know if this makes any sense. So per letter frequency, I don't know. So so we need to find frequency move up. Frequency by letter, and then we can frequency by position. uh or I range by position. By position, so I 0 1 2 3 4 1 2 3 4 5. The first, oops, sorry. 1 2 3 4 5. Okay, so 0 1 2 3 4. And okay, let's see if this makes any sense. That means to say for pause in position in I for all the word. Wait. If letter in wait. Wait, what? So for each letter, so I will take the pause. No. What? Wait. So for every word, so for every word, if this particular letter, is in then wait. Okay. So score by per letter frequency means to say that every word is for letter in no, now this is just for letter in word. No, for every letter in word. If word frequency by position for every letter, pause, enumerate, common pause for oh, my bad. Source. Ah. Okay, let's. Yo! What? Shit. Okay, hold on. This is surprising. Oh, it's not better. Ah, interesting. Huh. Hmm. 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 Okay. Mm, interesting. Uh, mm, so I'm just combining the score now. Looks to be a cheap way, but let's see if it's makes any sense. Let's just call it combine. Combine. What? Oh, I don't even know if the scores are necessarily comparable. Well, we'll find out. Probably makes things worse actually, because now things become more muddled, you know. Oh, it's a little better. Oh, it's a little better. Okay, let's make oh, what? Ah. Oh, wait, what? Wait, why is this wrong? What? Blue is not a bins. No, color. So unique is so letter unique is the most, of course. Per letter is less. What? Per letter is less? What? Oh, because you double count. Ah, so what if you times 5? Does that make sense? Okay, now I'm gonna try to do something weird, and it probably doesn't work, but whatever, let's just try it out. So score by entropy. So score by entropy. So I think I can do this. So if it's not inside my score by okay, so for every letter, if it's not inside, if the word is not inside, then it's so frequency by letter. Frequency by letter. Oh wait, so it's per letter. Okay. I don't know if this makes any sense. But it looks interesting enough to be tried. Okay, so for every word that's not in the night start, otherwise I add the frequency. So this one will be the frequency. Well, let's just call it prob divided by okay, so let's just say that values letter So let's just call it 1 0 dot values and then the list. Okay, very good. Oh, I don't even know. So entropy means that... Oh, this is an interesting question actually. So if I do score by entropy for something like a rose, not better, unique. Hmm. Source. letter. Frequency per letter. Not better. The entropy approach is not so simple, because if I compute like a new set of words, then the entropy must be with respect to the existing words. You know? Oh. Yeah, obviously there's something wrong here because I'm just using a uniform rule throughout, whereas the human is supposed to, other than just narrow it down, supposed to observe the situation, right? So if we take a situation where we have too many possibilities and we need to explore, we need to start narrowing things down, and then we need to see that all the remaining words, or all the words, actually all the words, not just the remaining ones, to see how much they can contribute to the old words. So I have to reevaluate the whole list with respect to the... Oof, how would it even be done? I don't even know. So for example, if I know about EARS, that means guessing ERS does not gain me any information anymore. Right. So words that are inside at 0 information. So actually guessing... Oh. Yeah, I feel like I might continue this another day. But so far you can see that the average, it takes about like 3.3. That's the best so far I have. 3.3. Yeah, so I don't know if I'm times 10. Blue, no. 6. The green combine. I want the blue and the red. Hmm. 4. This is random. Just random. Times 4. Hmm. So the next thing to do, let me just write down the few things to do. So plot difficulty, number of tries versus score. Harder implies lower high score, lower entropy, I don't know. And then take into account per turn decisions. Figure out entropy expression that makes sense. If we know, then guessing should only contain small information. Okay, so we have all these things. Okay, is it better? Color red, and then we have unique, and then we have combine, then we have entropy, and we have entropy too. Red, green, blue, black, orange. Okay, let's see. Yeah, not much difference. Maybe yeah. Okay. Anyway, so yeah, I'm gonna call it a night. I think this is, just been a bit of fun. Yeah, but I should, yeah, I'll keep thinking about this maybe a little bit, but, might or might not come back to this, I'm not sure, but it's been a little eye-opening, and it does ask a lot of interesting questions. Even though the game is so simple in its construction, it's a lot of, and it's very easy to code as a game, right? You know, anyone, you know, who can code can probably do it, right? You just check out what's right, what's wrong. It's the hard part is to have an ideal, like an optimum solver. So that's the interesting part. And so far, the best result I have is so far, I guess, this one. So if I combine the scores of per letter frequency and overall frequency and you know, the entropy, somehow get something better. Yeah, but they're all kind of the same, you know. I'm expecting something to be much better, but yeah, so this is like, by the way, this is +1, so you got a 4.4. That means on average you take 4 to 5 guesses on average, and there are words that takes, for example, 13 guesses. These are all 11 guesses. So 11 guesses. Yeah. So I don't know. Maybe it would make sense that in the start of the game you maximize exploration, and towards the end you do like a per the round you do a different scoring. There's a lot of things to explore, so we'll think about it another time, and maybe there'll be a part 2 to this, maybe there won't be. Either way, if you've been watching, I hope you enjoyed it. Alright, have a good one.